Hello friends. So in the last video we have solved the examples based on the derivative of exponential and logarithmic functions. Okay. Now here we are going to solve the examples using the logarithmic method. Okay. Means using the log method we have to simplify some of the examples. So first of all I will give you that general method to solve the problems. Okay, how that method we have to take or we have to apply to the problems. Okay, so let us see the general method of that to solve the further problems. Okay, so that is, suppose if you have the function that is y is equals to u to the power v, y is equals to u to the power v, where this u and v are the functions of x. Okay, so if you have any function of in this form, then your first step is what? Taking log on both the sides. Taking log on both the sides. So you have to take the log on both the sides. That is, log y is equals to log u to the power v. Log u to the power v. So this log y as it is, which is equals to. So in the first class I have given logarithmic properties. What is log x to the power n? That is n log x. See this property already we learned it. That is log x to the power n can be written as n log x. Means whatever the power is there, that power you have to multiply, and that log x you have to keep as it is. So here log u to the power v. So v is the power. So v we have to multiply, and log u you have to keep as it is. Okay, using this property. Fine. So once we apply the logarithmic property, the next step we have to differentiate. So differentiate with respect to x. With respect to x we have to differentiate. Log y derivative is 1 by y, but y derivative is again dy by dx, which is equals to v into log u. This is product of two functions, so therefore you have to apply the product rule. So first function constant, derivative of log u is 1 by u, and u derivative is du by dx, plus the second function is constant into derivative of first, derivative of v is dv by dx. Then this dy by dx as it is, this y we have to transfer, it will multiply, so y into this is v by u du by dx plus log u into dv by dx. This is your answer, or later you can substitute this y. Y is what? U to the power v. You can substitute it, and that will be your final answer. So this method we have to follow to solve the next exercise or the next problems. Okay, so let us have the examples. So first example, y is equals to x to the power sin x. X to the power sin x. So here I am not going to solve with all the examples, but I will solve some different type of examples using the same method. Okay, so here, so first we have to write taking log on both the sides. So instead of writing in sentence, I have written in short, taking log on both the sides. So therefore log y is equals to log x to the power sin x. X to the power sin x. Okay, so this log y as it is, which is equals to, now apply the logarithmic property. Log x to the power n is what? N log x. So log x to the power sin x can be written as sin x into log x. Sin x into log x. Okay, now so once we apply the property, we have to differentiate with respect to x. Derivative of y, so derivative of log y is 1 by y into dy by dx, which is equals to Now this is product of two functions, so you have to apply the product rule. So first function is constant into derivative of log x is 1 by x, plus second function constant into derivative of sin x is what? Cos x, or which is equal to this dy by dx is equals to y is dividing, transfer here it will multiply, so y into sin x into 1 sin x divided by x plus log x into cos x, log x into cos x. Okay, then dy by dx is equals to, so as I told you, to write the final answer, this y we have to substitute. What is this y? That is x to the power sin x, the given function, and this answer as it is. Okay, I hope you understood this problem. Now we will solve some more examples using the method. So the next example, y is equals to x to the power x minus 2 to the power sin x. Y is equals to x to the power x minus 2 to the power sin x. Okay, so whenever that y is equals to, if sum or difference of two or more functions, okay, then directly you don't take log on both the sides. First thing what we have to do it, that is, let denote this x to the power x function by some new variable, that is u, and 2 to the power sin x will denote by v. If there are three functions, then you can take u, v and w. Okay, now it is two functions, so denote by u and v. So therefore, what is y now? This is replaced with u variable minus this is v. So y is equals to u minus v. Now you differentiate this with respect to x. So derivative of y is dy by dx, which is equals to u derivative is du by dx minus v derivative is dv by dx. Okay, so I'll give this as equation 1. Now next step is what? You have to find using the logarithmic method du by dx and dv by dx. Okay, so now take the first one, that is u is equals to x to the power x, u is equals to x to the power x. So apply the log on both the sides. So taking log on both the sides, so what will get? Log u is equals to log x to the power x. Okay, then log u is equals to, it is x into log x using logarithmic property. So once you apply the property, next you have to differentiate with respect to x. You have to differentiate with respect to x. Okay, so in this right hand side is product of two functions, so therefore we have to apply the product rule for this. Okay, so left hand side, log u derivative is 1 by u du by dx, which is equals to, here apply the product rule, x as it is, derivative of log x is 1 by x plus second function is constant into derivative of first is 1, so which is equals to du by dx, u transfer to that side, it will multiply into x get cancel, 1 plus log x, 1 plus log x, or du by dx is equals to, what is u here? X to the power x in bracket 1 plus log x. Okay, now give this as equation 2. Give this as equation 2. Okay, now let us take the next. V is equals to 2 to the power sin x. Okay, taking log on both the sides. So what will get? Log v is equals to log 2 to the power sin x, 2 to the power sin x. So log v is equals to, apply the logarithmic property, so it is sin x into log 2, sin x into log 2. Now differentiate with respect to x, log v derivative is 1 by v into dv by dx, which is equals to, see this is again product of two functions, or else with respect to x log 2 is constant, so log 2 you have to keep as it is into derivative of sin x is what, cos x, or dv by dx is equals to log 2 into cos x. See here v, we have to transfer, it will multiply into v, or you can say dv by dx is equals to, now v we have to substitute, that is 2 to the power sin x into log 2 into cos x, and this is your equation 3. This is your equation 3. Now this equation 2 and 3 we have to substitute in the equation 1. So substitute 2 and 3 in 1 in equation 1. So equation 1 is what, dy by dx is equals to, first term is du by dx, so du by dx is here, that is x to the power x in bracket 1 plus log x, okay, minus dv by dx, so dv by dx is what, it is 2 to the power sin x into log 2 into cos x into cos x, okay. So this is the answer. So this is little bit lengthy, but it is easy, okay. So let us take next question, okay. So I hope that you have understood this example. Next again I will see of some different type. Y is equals to log x to the power cos x, log x to the power cos x, okay. So here again taking log on both the side, therefore log y is equals to log of log x to the power cos x. So this log y as it is, apply the logarithmic property, see this is log x to the power n, okay. So it is n into log x, but here x is what again, log x only, x is what here, log x only, okay. Now differentiate with respect to x, derivative of y is 1 by y dy by dx, which is equals to, this is the product of two functions, so therefore first function as it is into the derivative of second, but second function it is a type of composition function. So first derivative of log x is 1 upon log x into log x derivative is 1 by x, okay, plus, now second function is constant, this log of log x is constant into derivative of cos x, that is minus sin x, okay. So therefore dy by dx is equals to, y we have to transfer, it will multiply, okay. So here cos x divided by x into log x, here plus into minus, I'll write first sin x into log of log x, okay. So later you substitute the y value here, that is log x to the power cos x, and this bracket term we have to keep as it is, okay. So that is the answer of that example. We'll solve one more question. So let us take the next question. Y is equals to log x to the power x plus x to the power log x to the power log x. So here there are sum of two functions. So as I said, whenever it is y is equals to sum of two or more functions, so let us denote those by some new variable. So that is, let u is equals to log x to the power x and v is equals to x to the power log x. Okay, so therefore your y becomes what now? U plus v. Now you have to differentiate this with respect to x. So y derivative is dy by dx, which is equals to du by dx, plus v derivative is dv by dx. Now give this as equation 1. So to differentiate u and v separately now, that is, u is equals to log x to the power x. So taking log on both the sides, u derivative is du by dx. Sorry, we have taken log on both the sides. So therefore it is log u is equals to log of log x to the power x. Okay, log u as it is, which is equals to, see, you have to use the logarithmic property, log x to the power n. So n is x here, so x into log of log x. So once you apply the property, we have to differentiate with respect to x. Okay, so log u derivative is 1 by u du by dx, which is equals to product rule, x as it is, derivative of log x is 1 upon log x into 1 by x plus log of log x as it is into derivative of x is 1. Derivative of x is 1. Okay, we'll write the next step, or we'll simplify that. So this u you have to transfer, it will multiply. So du by dx is equals to u into, okay, so that is this x and this x get cancelled. I think left with 1 upon log x plus, that is what, log of log x, log of log x. Next, this u you have to substitute. What is that? U log x to the power x and 1 upon log x plus log of log x, and this is your equation 2. This is your equation 2. Next, and v is equals to x to the power log x. So taking log on both the sides, so therefore log v is equals to log x to the power log x. Okay, so log v is equals to, okay, now log x to the power n, here n is log x, so therefore log x into log x, or log v is equals to, okay, or can differentiate directly also using the product rule. Okay, so differentiate with respect to x, so it is 1 by v dv by dx, which is equals to first log x constant into derivative of log x is 1 by x plus second log x is constant into derivative of first log x is again 1 by x. So therefore dv by dx is equals to, okay, we have to transfer it to multiply. So this is log x upon x plus log x upon x. Now v we have to substitute. Okay. So that is dv by dx is equals to x to the power log x into, see, if you take the LCM, LCM is what here? LCM is x. So therefore you have to add the numerator. Log x plus log x is 2 log x. Log x plus log x is what? 2 log x. This has 3. Now we have to substitute that equation 2 and 3 in the equation 1. In the equation 1. What is your equation 1? That is dy by dx is equals to du by dx plus dv by dx. So therefore substitute 2 and 3 in 1. Okay. So therefore dy by dx is equals to, first is du by dx. So what is du by dx here? Log x to the power x in bracket 1 upon log x plus log of log x plus dv by dx, that is x to the power log x in bracket 2 log x divided by x, and this is your answer. Okay, so I hope that you understood these examples. Okay, so all it is there in the notes. You just go through the video and then later you just go through the problem. Okay, thank you.